I saw you say that.
All right, here we go. Who's up? Who's up for 1A? This should feel good for us. Michelle. All right, so we plug in f of 0 actually means to do 3 times 0 minus 5, and you get negative 5. Didn't you like that? And can we be honest? On the test, like, you know that question 2 has some, like, skills, algebraic sort of problems? You're going to see something like this. And you should feel good about that. You should be like, okay, I know, like, the skills I'm going to feel good about. All right, Michelle, call on someone for B.
All right, so 5 over 3.
All right, how'd you get it?
I made f of x equal the y equal to 0, and then I added 5 to those sides and 5.
All right. Did anyone do that, like, without actually writing anything? People do that in their head, or you still like... All right, so some people did. Some people actually like writing it down, and that's okay. As a reminder, right, when you're trying to show something on homework or a quiz or a test, you want to write it down. You don't want to just say, oh, yeah, here's the answer that I came upon. Like, you want to write, and you can see that's not that much to write. It's a couple lines. You can do it. All right. The next one... I think well, maybe you don't have to write down. You could probably do it in your head, but we should talk through how to do the next one, because the next one's a little different. Okay? Sam, call on someone. Danny, what do you got?
So you just plug 1 over a into x, so you get 3 over
All right, hold on. So wherever I see an x, I plug in 1 over a, and you get 3 over a minus 5. Okay. Evan?
Why wouldn't you distribute 3 and make it 3 over 3a?
No, because this isn't 3 over 3. 3 is the same as 3's thinking, oh, you know what I am? I'm 3 over 1. And when you learned how to multiply fractions, you learned to multiply the tops and multiply the bottoms.
I'm saying, like, wouldn't you distribute 3, so it'd be like 3 times 1 over 3 times 8?
No, I thought I was pretty clear in what I just said.
Oh.
3 is thinking, I'm 3 over 1, not 3 over 3. And when you learn to multiply fractions, you learn that if you have 3 over 1 times 1 over a, you multiply across the numerators and across the denominators. Okay? So we actually don't write the over 1 part. It's sort of implied, but I can understand. So in your mind, you need to be thinking what 3 is thinking. Okay? Fair enough?
Yeah.
Okay. What do we got? Is that okay? We like that. Do you remember, though, like, let's do this. What if I said, D? What if I said find f of, sorry, I'll make it consistent. F of x plus h. Does that seem like a problem maybe that you saw before? Yeah, maybe. On a homework, on a classwork, on a quiz. I think all those places maybe. This part, though, would you say this is easier than what was on the test? Yeah, because what was the test? The test was like
2.
Yeah. Yeah, it was like, it was a rate of change. It was like f of x plus h minus f of x over x plus h minus x, and not only did you plug in, you had to simplify it all. So this is an easier, like, piece of that. Sam Snyder, how do you feel about plugging in x plus h to this rule? Good, bad, or ugly? I don't think it's bad either. Talk me through it a little bit. I think it'll be like, I think you can say it in one sentence maybe.
I think, I'm not really sure, but you could do 3x minus 5 plus b. Or 3x plus b.
I like that better. I like that a lot better. Right? Okay? So, x is like a smiley face. And the rule says... It's not intended, sorry.
No.
Oh my god. Tough crowd. So the rule says take whatever it is that's in that, whatever that smiley face is, and do 3 times the smiley face minus 5. So do you see how that's what Sam did? If this is the smiley face, then you plug that in and you get 3 times whatever the smiley face is minus 5. Yeah, isn't it 3? Yeah. I'm right? Am I wrong? Tell me I'm wrong. No. Okay, alright, fine. Sometimes, Miles, I need someone to tell me that I'm wrong. I mean, this is true. Alright. You liked that. That's good.
We don't have to distribute.
Oh, okay, we can do that. Sure. So, Raphael is saying, like, my Algebra 2 teacher may have wanted me to simplify, right? This is actually fine, but if you want to do 3x plus 3h minus 5, and you know, like, the problem on the test, right? You had to do that, right, to simplify? I totally would agree. All right, so you feel better now? I feel better, too. That's good. Okay. Let's take a look at using the graph. Should I do the graph? Actually, no. Let's take a look at just using our calculator. Tell me what the function, what was it, 3x minus 5?
Yes.
3x minus 5. And just as a reminder, some of you have all seen this before. Some of you have done it before. If you want to evaluate 0, right, you can do vars variables, go over to y variables, and pick f of y1, and then you can just plug in 0. Whoops. Plug in 0, and that will evaluate what happens when you plug 0, and you get negative 5 out. We knew that, right? All right, so that's function notation on your calculator, right?
I knew that.
We did that. Didn't we do that? I know we did. No, Andrew said no. All right, so look. All right, so I taught you something today, right? Hey, nice. All right. He finally taught me something. All right, so alternately, if you go to the graph, and I'll just do, I think I'll do Zoom Standard. If you go to the graph, you can hit the trace button, and you can just type in 0. And that's another way of finding out what f of 0 is. You plug 0 in, you get negative 5 out, right? One's on the graph, one's using function notation. Is that okay?
Yes.
For part B of that question, if you want to find out when the function is a value, that's a much harder question for your calculator to do. If we want to find out when the function is 0, we could do calc 0, right? But suppose, whoops, let's go back. Where's back? I want to go back a page. But suppose I asked you to solve the equation, when does f of x equal 2? Well, you'd say, all you have to do is do 2 equals 3x minus 5, add 5 to both sides, divide by 3, you get 7/3. Psst, Peter and Evan, up here. I know, I'm just saying, look up here. All right, so your calculator would get x equals, by hand you get x equals 7/3. If you want to do that on the calculator, if you want to find out where the function equals 2, you really need to, look what happens if you go to the table. In this case, you made me, all right. Now, remember we did this? We did the auto and the ask thing. Was that this class?
Yeah.
That's table set, second window. And I'll just do 0 and go back to table. Okay, so look, it doesn't look like, if you just look at the table, it doesn't look like the function's ever equal to 2. Well, alright, it is. It's equal to 2 between what two numbers? Jennifer, what two numbers is it equal to 2?
I can't really see the board that transferred.
Oh, sweet. Sorry, I didn't mean to call on you then. I apologize. Rafaela, what two numbers is it going to be equal to 2 between?
I don't get what you're at.
Andrea, you do.
Between 2 and 3.
Alright, so somewhere between 2 and 3, the function is going to be equal to 2, right? Right? So when is the function going to be equal to 2? Somewhere between 2 and 3. Now you could set your table to get you better and better estimates, but do you really think you're going to get 7/3? Like, using, probably not. Like, you're probably not going to get that on a table. But what you can do is you can do y2, and you can say, let y2 equal 7/3. So, in this case, you don't have to. You can, though. You can never be too cautious with parentheses, but 7 divided by 3 is the same as parentheses 7 divided by 3. All right? And if you graph this, really you're asking yourself, when is this equal to that. Right there. So let's do second calc. Let's find out where those two lines intersect. Enter, enter, enter. And they intersect. What happened? And I messed it up. All right, let me try that again. Where do they intersect? Enter, enter, enter. And it tells me they intersect when x is equal to 2.4 repeating. Wait, what are we trying to find out? No, I did this wrong. Why did you make me do that? I'm trying to figure out when is this equal to 2, not 7/3. I want the answer to be 7/3. Keith.
Sorry.
All right. Let's try that again. I'm sorry. Everything applies. So when is this equal to? So I can do second calc intersect. Enter, enter, and then enter. And it tells me when is it equal? At 2.3 repeating. And if you are unclear, I don't know if this is going to work. Just hang out with me for a second. It may or may not work. I'm going to go to second quit, and I'm going to hit the X button, and it's going to write 2.3 repeating, because that's what my latest X value was. And then, just because I think it can work, I'm going to go to math, fraction, and it tells you the answer is 7/3. How cool is that? All right, so we got it two ways. All right, by hand and by the calculator. Is one way better? No, but if someone asks you to do it one way, you need to be able to do that. Evan, then Monty, maybe?
I understand,
Okay, I do too. Go ahead.
When you were finding that, you went into a second calc intersect,
Yep.
and then it asks for the curves, right? So
Yeah.
First curve, second curve. So like, what is I understand.
First equation, second equation.
So I mean, is that like is first curve the equivalent of left bound and second?
No.
Equivalent of,
If you have like a bunch of lines there,
yeah.
right? You might want to, if you have like 3 lines, you might want to find the intersection of the first and second line instead of the first and third line. So you have to tell which 2 do you want to find the intersection of.
So does that mean you need to have one point be on the one line and the other point be on the other? Like you couldn't put 2 points on the same. Okay.
No, it won't let you do that because it would be like, oh, it intersects everywhere.
Okay.
Sam.
I understand how you got to the tree, but I just didn't understand when you were doing, like, you clicked on the point and got the...
I didn't click on the point. We did second calc intersect, right? And when we did, is this what you're talking about? And we hit enter, enter, and then we took a guess and we got an enter, and it ended up, I think I messed it up already. Was that all right?
Yeah, I guess.
Oh, good. Glad to hear it. All right. So let's go back to this. Let's take a look. We're going to estimate. All right. Sam Roseanne's for B, for 2A. What do you think f of 2 is about using the graph?
It's about 4, maybe a little bit.
So Sam's saying f of 2, the y value is 4. And that's what this is asking. Whenever it says f of something, it's saying, what's the y value? How high above or below is the function at 2? Are people okay with Sam's answer? I am. Are you? Do you want to ask any questions on that? Good. All right. All right, Sam, calling someone to answer B. What values of x where f of x equals 2? And before you answer, Evan, how many, is it value or values?
Value.
How many?
3.
All right.
0.
All right, I just want one from you, but are people all right with that? There are 3 values where f of x equals 2. All right, go ahead, Evan.
8.
Where you're going with 8?
Yeah.
Okay. So Evan says f of 8 equals 0. Sorry, not 0. 2. I agree. Evan, calling someone for another value.
3. Oh, thank you. 4.
F of 4, I agree, equals 2. And Keith calling someone to give us the last value. f of 0 equals 2. I agree. As a matter of fact, if you can picture, the horizontal line, that is the line y equals 2. That's exactly where that intersects at those 3 points. Is that okay? Do you want to ask any questions? Jennifer, how you doing without your glasses?
No, fine. I just couldn't see the exact. I can see most of it. Just I couldn't see
The little things are like, okay.
I could see like the equations.
All right.
Like, underneath it.
That's fine.
So, like,
Just checking in. Tom, thumbs up. Question? You sure? Andrea? All right. And let's see. Let's take a look at 3 and maybe do a couple of these, and then I'll get you tests and homework back. This looks a little bit, not exactly, but a little bit more like maybe what we were doing with the test, right? All right. So before we even do it, do you think there's a difference between A and B and C? Or do you think we're all going to get the same for those?
Different.
We think maybe there's going to be a difference? All right. I want to do A first. So can someone talk me through how I would do A just to set it up, and then we'll simplify? Monty, can you talk me through how I would do it?
F of A minus 2 equals A minus 2 squared plus 3.
Do you mean quantity of A minus 2 squared plus 3? So do you see what Monty did with the rule? He said, whatever goes in here, I'm going to square it and add 3. See what he did? All right, let's do a little bit of algebra. Can someone tell me the wrong way to simplify? Max, can you give me the absolute wrong way to simplify A minus 2 quantity squared?
A squared.
Perfect. Couldn't be more wrong. Thank you. That's what I was looking for. We actually need to FOIL it, and you can write it out if you need to. That's going to be what? A squared minus 4A plus 4 plus 3? Gesundheit. Or A squared minus 4A plus 7. All right. Is that all right?
Yes.
Questions, comments, concerns? Nice job, Monty, and thanks for the wrong answer, Max. B. F of A minus F of 2. Danny, you want to start that one?
Alright, so first you have to do f of a, which would equal a squared plus 2.
All right, so Danny says we're first going to do F of A, which is A squared plus 3, so I'm going to say this. That's that part, okay? All right.
And then then you subtract from that f of 2, which is 4 plus 3, 7.
All right, so I'm actually going to say 4 plus 3, and I'm going to get 7 in a second, but I'm going to make sure that I put parentheses around it. Those parentheses are important. And we'll do that. All right? Does that work for you? Do you see exactly what Danny was thinking by using those highlighters? All right, so let's do a little simplifying. A squared plus 3 minus 7, which is A squared minus 4. Already it's different from our answer that we got in A. So you were right. They are going to be different. Questions for B? All right, let's do C. Michelle. Oh, yeah, go ahead.
Can you simplify A squared minus 4?
Oh, you want to turn it back into like A plus 2, A minus 2?
If we were on the test or something, should we do that?
They're both pretty much as simplified as one could be. I think it's a matter of preference. Certainly if you factor it and there was something in the denominator, like it was a fraction, it might be good to factor because maybe something would cancel. Yeah, it was a nice question. All right, Sam.
Alright, so you already have A squared plus 2.
Sam's saying, hey, why don't we just steal some of the work that Danny did?
And then minus 2.
Whoops. Hold on, I'm getting there. And that would be that part. A squared plus 1. All right. And then Michelle would say, oh no, A squared plus 1. Never mind, Michelle would not say. Okay. Is that good? All right.